Hello and welcome to my next video on Nintendo 64 programming in C. In this video I'll show you how we can create a virtual file system and load in 2D images rather than create arrays of 2D pixels like in the last video. So one thing I'll quickly point out which I got wrong in the last video was I said there was a 32K cache for the RCP, when what I actually meant was it was a 4K cache which could support a 32 by 32 pixel image. So just to reiterate that, it is only 4K. Not that it will matter too much in this video, as we will be using the software drawing routines in LibDragon. So let's get straight into it. So what I'll do first off is I will show you the example. It's basically the same as the last video's example, except I've changed some of the graphics. So this is using the LibDragon's software sprite drawing routines. I find them to be a bit slower than my blitting routines from the last video, but obviously the advantage of using the LibDragon ones is that you can just load in various images, and they have a graphics converter tool which will automatically convert the images to the relevant format. So this is using 16-bit graphics again, and we can move around our playable character, which is the Motorbug character right here, and then if you press A you can change to some of the other graphics. As you can see here, we've got some different tiles. And then you can change the background with the B button. Here we are in the Simpson home there, like, and then back outside. And then we've got the frames per second there from LibDragon itself, and then below it is the S2D module with its frames per second, and then it tells you what the missed frames amount are and the updates per second. So bear in mind this is running on an emulator. When you actually chuck it into the actual N64, these numbers will be very different. Hence I say that my in the previous video the blitting routines give better performance than this here. I suspect it's because there's a load of different functionality which their software sprite drawing routines offer, which my blitting functions don't. So let's jump into the code here. So most of this is as it was before, so I'll go over the differences. So one of the main differences is we need to enable the disk filing system. So what that allows you to do is to create an assets folder in the root of your project here, and then in there you can literally drop in the images which you wish to load. It really is very simple. And then to enable the disk filing system, just use the DFS init function with DFS default location. So this kind of creates like an extra space in the ROM cartridge where all of these files would be located, and then you can access them as if it was a disk system, as and when you need. And then what we need to do is to load in these images here. So I've got like a list of the files. So the path that you use excuse me, should always start with a ROM, and then you have the first name of the asset without the extension, and then you put sprite on the end of it, .sprite, and then this would be the order which it kind of loads these in. As you'll see here, these names need to be the same as the assets in the asset folder. And then you use the LibDragon sprite load function. These are returned in the sprite structure of LibDragon. So I'll bring the header and the source side by side here. You can see what's actually going on. So this time we have a fixed array of sprites, basically. If you have a look what's in the sprite structure, gives you an idea here. The key thing to bear in mind here in this structure is there's things called H slices and V slices. So if I bring up one of these images here, for example, mystery block. So this image consists of 4 sub-images. So this would have 4 horizontal slices and 1 vertical slice. However, you need to specify these slices when you load them in. And to do that, when you use the make sprite tool, as I'm doing here, to load in your assets, you put the name of it and then a colon, and then you can put some make sprite flags. So one of these is format, and then you put the graphics type. In our case here it's RGBA 16. You could change these to RGBA 32. However, if you decide to do that, then you'll also need to make sure that when you initialize the display set up for the N64 that you change the depth to 32-bit as well. I won't be doing that here. So then when you after you've put the format flag and you pass in the format, you can then specify the tile sizes, and then when make sprite automatically loads that image, it will then note that it consists of subtiles, so H slices and V slices, and then carve the image up into those sizes for you automatically. So you see here we've the first one is we've got a min sprite 8 and excuse me, sprite 10. So if you look in our assets here, it will automatically convert this image into slices for us, as long as you pass these in. If you don't pass these in, then it'll just be like one large image when you try to draw it, and you won't get the subtiles. So all of the images which are split into tiles, you need to specify here. If this is like a generic command here, which will pick up all of the assets from the makefile here. So for example, the background images, you do not need to specify them in here, as there are no tiles. It's literally just one image, as you can see here. There you go, there's one image there, like so. You don't need to specify anything else. This makefile format here I pretty much use for all of my own sort of programs. The only thing you'll need to sort of change will be whatever sort of graphics you add here. And then you'll note here that there's a line for loading wave files. Obviously there's none in this example here. And I'll explain about those in a later video. So let's get back to, in fact first I'll show you how easy it is to just add additional images here. So one thing to note here is because it's obviously a fixed array, if you use this code to build off of yourself, just make sure you change the amount of images to reflect how many you have in your project, otherwise you'll throw an error, as you won't have enough. And then you also need to make sure that every image is actually included in this image array here. And then it's also best to add in some details about your graphic image, as I did in the previous video. So you'll see here I note the start of the ASCII character, and then how many characters are actually in the font set for each of them. And then using these enumerations here, we basically match up the order that we load these in. So when we wish to use these images, we can literally just refer to the ID number in the array where that sort of sprite is loaded. So what I'll do now is I'll switch out a few characters. So we'll remove the coin, and replace it with a ring, and then we will remove Motobug, and replace him with a skeleton dove. So I will copy these two in from a different folder here, and then if I open these up in LibDragon here, you can see them. So here's the sort of generic sonic ring animation, and then here's one of the skeleton turtle doves from Mario there. So now what we need to do is make a note of the asset names in the make file here. So let's see, where have we? So we'll comment out Motobug. And then if I bring up, in fact, just close these a minute. So we've got the ring there and the skeleton there. So now we need to change the asset names now to reflect them. So you'll need to create this assets folder yourself, and then what happens is once you build the ROM, which I will do now, of course it's because I've changed the names, so I need to go into the title screen here and then replace that one there with whatever I called it, which okay, and then we need to do the same for the ring as well. Let's try that again. There we go. Now what we should be able to do is load that in again, and then you'll see there that the rings have a did I put in a size for them? Okay, so the rings are working, the skeleton one isn't though, so what have I done there? Let's have a look. Oh, I didn't, it's not loaded it in properly. There we go. Let's try that again. There we go. See that's fairly simple there. And then what actually happens is once you build that, in the file system folder here, you'll see that these files are all generated. So the names in the asset file array basically need to match these here. And then these here are obviously being added to the actual ROM here. There's an area in there where these files are actually added. So now what I'll do is I'll quickly go over the what's actually changed in Scene 2D. So the code for drawing everything has changed slightly. As you'll see now, we have just sprite and image here. And the reason for that is there are two different LibDragon commands. For drawing images which have transparent parts and ones which do not. And then there's also two other commands for drawing sprites which have tiles inside them, so sprite sheets basically, and ones which are single images. So these in the draw graphics command here, if you go and have a look at that, these are the actual LibDragon commands which hand over drawing here. So you have a graphics, draw, sprite. So if you remember from the last video, we need the display or rather the surface structure which holds the frame buffer. And then basically that structure is passed in here. We kind of have like a global surface T structure. The display is requested and captured in that pointer, and then that pointer is then passed to the draw graphics function, which has the various LibDragon calls in there. So to draw a single image, you use the graphics draw sprite command, and this expects a sprite which has no transparent parts in there. So basically you can think of that as like a background tile, as long as it has no transparent parts, or like an image. So all the pixels should be solid in that image there. And then the other graphics command which we use for drawing the background tiles as well is the draw sprite stride command. And then what this does is, dependent on the sizes of the tiles you specified in here, you pass in a number which represents the subtile inside the image. So if I open up the mystery block image again, so this would be tile 0, that would be tile 1, 2 and 3. If it had more tiles inside, so if it was a sprite sheet with all of these different tiles inside, then that would be tile 1, sorry, that would be tile 0, 1, 2, 3, that would be 4, so it goes across and down. So that's how you would reference those tiles inside there. And then to draw the images which have transparent parts, they provide two other commands, the graphics draw sprite trans and draw sprite trans stride. And those do basically the same as the normal ones, except they obviously don't draw the transparent pixels. And other than that, everything else is pretty much the same in here from the last video. I think one of the other things I kind of changed was no, I think it's all the same. Like, so just like the last video, one thing to note with the N64 is lots of these commands potentially to get the display or working with the sound side of things. Lots of these commands potentially are blocking commands where you request to use or do something, but you have to wait for the N64 to have finished what it's doing before. I find it's best to not block and wait, because otherwise that will cause noticeable stuttering in the program, which is why I go down the route of using the try and get functions like this one here. So what this will do is it will try and get the display pointer. If it does, then you can start drawing stuff. If it doesn't, then you just have to wait until it has got the display. So that's pretty much it for this video. It's mainly just to show you how you can load in different images rather than using the DS to tile to convert them. So it's also worth looking at the other various graphics commands as well in here, which you can do. So there's some to draw pixels, lines and boxes. You can fill the screen, a set color as well. So that's it for this video, just a quick one, but it's obviously very much needed to show you how to handle working with assets here. So in the next video I will go over the hardware sprite drawing commands, and then I will also add in a little game as well, just to make it more interesting. So thanks for watching. Leave any comments below and I will get back to you when I can, and I will catch you in the next video.